Okay, so we are about to start. So take out your notebook, writing pad, anything that you want to write down. Okay, so for your information, this one will also be recorded. So I'll post it again just for the sake of revision anytime in the future. Right. Okay, so pressure. So we talk about pressure, chapter 3. This is I think chapter 4 in your newer syllabus. Chapter 3 or chapter 4. Okay, never mind. Now, pressure, simple definition of pressure. Okay, you can just jot down this one. It is defined as magnitude of the force acting perpendicularly to a surface. Okay, now magnitude of the force acting perpendicularly to a surface per unit area. This is the keyword. Okay, surface per unit area, meaning that if you take a look at the example, the formula of this pressure is P equals to F divided by A. Now, anything that divided by A is, we call it per unit, right? Meaning that we are interested in knowing for every 1 unit of area, what is the force acting on it, okay? So later I'll give you more example, okay? So force, 记得我们的 SI unit，okay? Force SI unit 是 Newton，area 是 in meter square，所以我们的 pressure 就是在 Newton meter square slash meter, or more commonly we write as Pascal, PA. Okay, now when you heard about Pascal, then it's all about pressures. Okay, now to give you a picture of this one, pressure, let's take a look at these two boxes. For example, let me draw this one. So the first one, cuboid, and the second one, same but just different arrangement. Okay, okay, this. Now, which one has the higher area of contact? Okay, so you look at the area of contact, meaning that if you place these two solids on a table or any surface, right? So there is a contact between the surfaces. Okay, so there is the base lah. The base is in contact, right? So this one, if I say, for example, this one, I put it, the area in contact is 10 meters square. Okay, and the area of contact for this one is just 5 meters square. Okay, so this one has a smaller contact area, right? Now, if I say the two boxes, they are of the same weight, they have the same weight. Okay, so I label this one W, weight. This also pointing down W. Now the weight is 500 Newton. Okay, now both solids having the same weight, but they have different area of contact with the surface, right? So if you were to place these two solid on a muddy ground, let's say you put it on a muddy ground, right? So which one will sink deeper? You will see that the second box, it will sink deeper into the ground. Why? Because simply because it is exerting a higher pressure compared to the first box, even though they have the same mass. It is because of the area of contact. Okay, so you can think of pressure is like the force, how the force is distributed over an area, right? So you can write down this one. It's like pressure is how the force is distributed over an area. Distributed means 好像散发这样啦，不是好像 like spreading, yeah, spread out. Okay, how is it spread out over an area? If you have a large area, meaning that the force will not concentrate on one single point. All right, I repeat my statement. If you have a large area, meaning that the force will not concentrate on single point, so therefore it is spread over the area, which is why you have less pressure acting on the surface. Okay, now if the area of contact is very small, just like our block B, right, is very small, focus on one single small area. Okay, for objects having the same mass, it is going to exert higher pressure simply because the force acting over the area is more focused, more concentrated. Right? So which is why we say that pressure is how the force is distributed over an area. All right? So you can also say that pressure, it is the how much is the force acting on one unit area. Okay? So this one, so let's say we do the calculation. Okay, simple calculation here. Calculate the pressure acting by block 1, the first block. So P equals to F, P equals to F divided by A. So 500 Newton divided by 10 meters square. So you get 50 Pascal. The second one, P equals to FOA by Newton divided by 5 meter per second. So this one, you will get 100 PA. Okay, so you notice that this one, of course, it exerts a higher pressure. Okay, Edison is here. Let me allow me. Still connecting. Okay, yeah. So Edison is here. All right. So wait. Okay, Edison， 如果前面你们小一点点不用紧，我有 record 下来，过后我也是会 post 去 group 啦。OK， 所以你可以看回。All right, let's continue. So this one, the first one, so you can say that the first one is, this one means that 50 Newton of force is acting on 1 meter square area. All right, so this one is 100 Newton force acting on 1 meter square area. Okay, so as a result, you'll see that the first block will sink deeper. Okay, now if you look at the formula, right, P 等于 F over A， 如果一样的重量或者一样的 force， 我的 area 越小，你看那个 formula 啊， you use the mathematical logic to figure out this one. If your area is small, that will make this whole fraction becomes bigger and bigger, right? Because if you divide a number by a very small number, it will become a big number. Okay, the smaller it is, the bigger is this pressure, right? So if you divide something by a very big value, you'll get a very small value. Okay, which is why when the area increases, the pressure will decrease. Okay, so you remember this is the relationship between pressure and area. 如果我的 force 是固定， area 越小 pressure 越大， area 越大 pressure 越小 is the same as if my area is the same. For example, if my area is constant, then 我的 force 越大 of course 我的 pressure 就越大。 Okay, now you can see the application of pressure in your everyday life from, it's like literally what you see lah. Okay, you see, I give you a few examples. Okay, maybe you can take note of this one first. You take a snapshot if you want to take snapshot, because I'm going to erase this. Okay, so application of pressure, this one is all in your book, but I'll give a few examples just to let you more understand how it is used in our daily life, right? So first one, cutting tools, right? So why is the knives or any cutting tools they make very sharp? Because they want to decrease the area of contact. Okay, because they want to decrease the area of contact, because the smaller the area of contact, the higher the force. Okay, so if you look at the knife, right, this one is, let me draw it out. Okay, this is, for example, your cutting knife. So if you like zoom in here, the edges, you'll see that not only it is sharp, but it is designed in a way that has this one very pointed parts. It looks like this. We'll draw it out like this. Okay, this one is actually very small. You have to take a closer look, only then you can see it. Okay, so this one, not only the edges is made very sharp, plus it is designed in a way that so that it has this pointed sharps, okay, further decreasing the area so that it makes the cutting easier, right? So it's the same thing. So second one, what else? You have the football shoes. Okay, if you look at football shoes, this is the shoe. So at the bottom you have this spikes, right? This one spikes. So what is this for? Without the spike, without the spike, okay, the pressure acting on the ground, okay, will prevent the player to have a grip on the ground. Okay, so this spike functions to reduce the area of contact and it increase the pressure on the track. Okay, so that the player the football player, right, if they can have a better grip. Okay, this one. So this one is the same principle of pressure. What else? You have like what else? You have wheelbarrow. Okay, wheelbarrow. Okay, let me draw it out. Like, looks like this. Okay, this is the wheels, and then yeah, this one is the same thing. You know, sometimes you notice that they put a wooden plank underneath, like a 它放一个板啊在下面这边。Why? Because without the wooden plank, what happened? The wheel will exert a very high pressure on the ground. Okay, so all the weight, like the weight of this wheelbarrow, right, is concentrated on the tire here. So by putting a plank, you increase the area of contact between the ground and this one. So it becomes like this. This is the area of contact. So you have the same force, the weight acting down, but simply if you put a wooden plank on top, underneath, then you can reduce the pressure tremendously. Okay, so it's the same principle. It's also why? Because it increases the surface area of contact. Okay, the keyword is increases. Okay, this one is increase surface area of contact. Okay, so these two is the first one is what? We reduce the area of contact, right? This one is we reduce area of contact. Okay, this mistake here. This one also reduce the surface area of contact. So all these three applications shows that we reduce the area surface area of contact. What else? 你的书包，你背书包的时候 ，the strap 啊，你的书包的那个 strap，OK， 你会看到有那个resting pad，OK，there's like draw it out here. This is your bag. Okay. So this is the strap. So we zoom in here. It looks like in the middle they have this very thick resting pad. So this one also, why is that for? Also increase the surface area of the strap between the strap and between your shoulder. Okay, so that you don't feel that much pressure on your shoulder. Okay, so you see this pressure application everywhere, right? Now, the keyword is reduce and increase area of contact. So if whenever you do the question, right, every time you do pressure question, always they want to ask you this one. Why? Why this one? Why that one? You use the same keyword, reduce the area of contact, or increase the area of contact, then you get a marks. Yes, you get a marks. Okay. Reduce the area of contact, thus the pressure becomes what? Increase the area of contact, thus the pressure becomes what? Here's how we explain it. Okay. Now, next. Okay, just now that one is the general form of pressure. Now we look at pressure in liquids. Okay. Now, if you look at pressure, where does pressure comes from? It comes from the weight. Let's take the example just now, the two blocks. You place it on a surface. Where does the pressure comes from? It comes from the weight of the block, right? The keyword is the weight. Now, if you look at pressure in liquid, same thing. It comes from where? It comes from the weight of the liquid. What do I mean by that? For example, if you are swimming, this is you're swimming in the sea. Okay, now you dive until a certain depth. Okay, so what happened here? At this point in the water, right, you are actually withstanding the weight of the water on top of you, right? So if you look at the region, the upper region, any point above your body here is the weight of the water. Okay, so the weight of the water, the entire regions, right, is acting on your body, which is why sometimes you feel very difficult to breathe when you dive deeper. Right? So the pressure of liquid simply comes from the weight of the liquid. Okay, and also you'll realize that the deeper you go, right, the deeper you go, the more difficult it is to breathe. Okay, and for human, there's a maximum depth we can go, which is I think it's around 60 feet. Okay, 60 feet. Below than that, that will cause 生命危险. Okay, no, it cannot. Right? So there's a maximum depth we can go, which is it's all because of the pressure. It's too high. Right? So if you look at the pressure of liquids, if you fill up for example, if you fill up a pail with water, right? So this is, we have holes here, for example, and then you fill up the water here, you lift it up, you'll see that all the water flows out from these openings. Okay, at the same time, simultaneously, they flow out. This simple experiment proves that water acts in all directions. The pressure of water acts in all directions. Okay, now water, you can say that water flows out in all directions, or you can say that pressure acts in all directions. So any solid in the water is acted on every surface. Okay, every surface of the solid is acted by the pressure of water. Right? It's all directions. Okay. Now back to this one, the ocean one. Okay, so you know that the pressure increases with depth. The deeper it is, the higher is the pressure. Now let me ask you something. Do you know that where is the deepest place on Earth? Just think about it. Maybe some of you know. Where is the deepest place on Earth? Yes, Mariana Trench, Edison. Yes, Mariana Trench is the deepest place on Earth. So it is located at I think it's nearby the Philippines. Yeah, on the west, east. I think it's east in the Pacific Ocean. Okay, so on top right, if you look at the satellite, the map, it looks like a crescent shape, like a moon shape. Okay, this is the Mariana Trench. You can see it from the top, even from the top, the satellite view, right? So if you zoom down, it is actually a trench. So what is a trench? A trench is like two It's like there's under the water, right? There's many mountains, right? So it's like you have one mountain, and then this is the 它的一边那边是，然后你有第二个 mountain 一边，然后 they join at one point here, so they form a trench. This is what we call the trench lah. So it's like a ditch. It's like a longgang lah, right? It's like a ditch. So this one is the deepest place. We call it the Challenger Deep. This is the name of this place, Challenger Deep. Why they call it Challenger Deep? Actually, there's a story like back in like 1865, I think around that 18th century. They did an experiment. They want to find out how deep is the Mariana Trench. Okay, so what they do is they take a very heavy object and then they tie with a rope, very long rope. Okay, and then they put it down. Okay, they want to measure how deep is it. But at that time, right, because they don't have the technology, we have now, the echo sounder to measure depth. So this is the only way to measure, but it is not long enough. So what they measured during that time is that they thought that the deepest point is only until 9 kilometers. Okay, this is what they got during that time, 9 kilometers. And then after a few centuries, like in 1965, a few centuries, 100 years, okay, they start to have this technology, the echo sounder. Okay, 他们发出那个echo wave, 然后反弹，然后他们就量那个the depth, right? So the true depth of the Mariana Trench is 11 kilometers. If I'm not mistaken, it is 11 kilometers straight down. Okay, it's straight down and not slanted. It's like straight down. Mount Everest is only like 9 km, 9 point something km. Okay, so you can fit Mount Everest in the Mariana Trench, right? So the pressure at the deepest point is about 1,000 times of the atmospheric pressure. Okay, atmospheric pressure is the pressure at sea level, at ground level. Okay, the level we are at right now is 100 times. Okay, so what is the maximum depth human can go? It's only 60 feet. Maximum depth is only 18 meters. Okay, you swim until 18 meters down, then you will feel the pressure acting on. Very difficult to breathe because the pressure is preventing your lungs to expand. It's preventing your lungs from expanding, which is why you feel difficult to breathe, right? So at the deepest point here, what is there? We don't know. It's like total darkness, right? Total darkness. The aquatic animals is also different. Very weird animals because they have to sustain the very high pressure, right? So it's like total darkness. So throughout the years, all the scientists, they have been doing a research on what is down there. Okay, so we're something like we're still waiting for the answers. Okay, they found a little bit like some aquatic animals there, and some other like collatin. 我也不知道怎么找到 collatin 在那边。Okay, okay, so that's it for that one. Now back to this one. Pressure in liquids. Now let's derive the formula for pressure in liquid. Now you know pressure is P equals to F over A. Let us think of it in terms of liquid. Okay, now let's say I draw a container. Imagine this is a container filled with water. Okay, now this is the height of the container. This is the width or the base, and this is the length. Okay, here is the base surface area. I just write SA lah, surface area. Okay, so on top is the surface of liquid. So from the formula P base, if you want to calculate the pressure acting at the base, I write P base equals to F over A. Okay, now F, the force of the liquid, meaning that the weight of the liquid. Okay, the weight of the entire liquid in the container. What is that? You know, you learned that F equals to mg, right? F equals to mg over A equals to, now M is the mass of the water. Okay, so you know that density of water equals to mass per volume. So mass equals to volume times, no, sorry, density times volume. Okay, so if you substitute inside, you get the density of water times the volume of water times G over A. Okay, now from here, this volume is base times height, right? Area of base times height. Okay, I just put A. I write A term H. A is the base area. The base area times the height is the volume, right? So I put down density times A times height times G divided by A. So you can cancel off this one. You will get H rho G. This is the pressure of water, right? So if you are asked to derive this one, then this is the derivation. Okay, so pressure at any point in the liquid is equals to the height, the depth, sorry, not the height, is the depth times the density and the gravitational constant. Okay, P equals to F rho G. Okay, you can take a snapshot this one if you want. Okay, simple calculation here. Sea level and then submarine depth is about, so density of the sea is like 1025 kg meter per cube. G is 10. So if the depth is 600 meter, what is the pressure at this point? Okay, so straightforward calculation. P equals to H rho G. Depth 6,000 times density 12025 times 10 equals to 6.15 times 10 power of 7 Pascal. All right. Steps to calculate the water pressure. Okay, now application of water pressure. Right, so there are a few applications. The first one is the dam. If you look at the dam, what is the dam? Used to store the water. Okay, a very high wall they built to store the water, and then they channel the water to turn the turbine, right, to generate electricity. Okay, you learn about all this. Okay, so the channel is at the bottom here. If I were to draw it out, this is the water, this is the huge wall, and then here they have the generator. Here they have the turbine, and then the water, something like this lah. Okay, you will notice that as you go deeper and deeper, right, the wall of the reservoir, the wall of the dam becomes thicker and thicker. Okay, why? Because as you go deeper, the pressure increases, the pressure of water increases, which is why they need a thicker wall at the bottom. So every time you see all the dam, right, their thickness increases down the depth, right? Because they need to withstand the high pressure, otherwise it will break. Okay, so same, why does the channel is built very at the bottom here? Okay, because we want high pressure to turn the turbine. Okay, basically turbine is like a rod and then fitted with all the blades. 就很像你的风扇啦。Okay, so when the water flows through it, the turbine turns. It is designed in a way that to allow the blades to turn easily. So back in university, right, this is actually my project. I did this project like to study how the water turns the turbine. Okay, so you have to design like a turbine. How does the blade looks like? So if you like top view, right? Let me draw it out. From the top view, your turbine actually looks like this. This is the shaft, and then your blade is like this, and then like this, and then like this. Okay, it is like a curved shape. Why? Because this curve, right, we want to contain the incoming flow of water. So water basically water flows into this concave shape. Okay, so you have to design it. It's very complicated. You have to design like how is it curved. Okay, what is the radius you need to decide. Okay, to maximize the flow of the water. Okay, to maximize the energy that you get from the water. Okay, so it depends. So this is actually my experiment back in my final year in the university. Okay, now second application. What else? This one. 那个什么吊水 right? Look at in the ward, right? They use this one, the neutron bottle. Why they have to hang it up high up? Because they want high pressure at the other